Hello and welcome to this video out of my series BGP for Networks Who Peer. I'm Wolfgang from the DE-CIX Academy. If you're interested in more videos, have a look at our YouTube channel or check the DE-CIX website at decix.net/academy. This video series explains BGP, Border Gateway Protocol, for network operators or for everybody who wants to know how large-scale routing in the internet works. So BGP for Networks Who Peer, the first video, what is BGP about? And here we have an overview of all the other videos. Today the first one, what's BGP about? So BGP is about prefixes, network prefixes. You all know about IP addresses, so what's now a prefix? An IP address actually has a host part and a network part, and an IP prefix is just the network part. Here we have an IP version 4 prefix. IP version 4 addresses are 32 bits long, and what you see here, a so-called /22 network, means that we have 22 bits in the network part and 10 bits in the host part. So the number after the slash is the number of bits in the network part. IP version 4, of course, you know, addresses are 32 bits long, and even if we write them in decimal numbers with the dots in between, actually it's just 32 bits. And /22 in this case mean 22 bits in the network part, and as a prefix the host part is all zeros. IPv4 prefixes, and you might have heard about so-called class ABC networks. That has been obsolete now for more than 30 years. So for more than 30 years we are doing classless routing, we call it. That means the number of bits in the network part is variable, and you note it with the slash and the number, /22 in this case. The same is true for IP version 6. Here addresses are 128 bits long, and we write them in hexadecimal with the colons. So numbers from 0 to 9 plus letters from A to F, hexadecimal with the colons. But in reality, we also have addresses as bits. And we have here a so-called /64, that means 64 bits in the network part. And this is what BGP is doing. BGP deals with prefixes. And how does it do that? How does BGP work? BGP is a protocol which announces prefixes. So my network, I am AS196610, the DE-CIX Academy, and I'm announcing this prefix. That means this network, this prefix is located in my own network, and I have hosts with IP addresses out of these prefixes, and these hosts can reach through me. And I'm announcing that to my network neighbors. Here we have a neighbor, and he says, oh yes, my neighbor, my blue neighbor, AS196610, announces this prefix. This prefix is located at my neighbor. And he re-announces that to his neighbor. So his neighbor here in orange says, oh, my green neighbor told me that this network prefix he's announcing is located actually at the blue network over there, the DE-CIX Academy. And this is how BGP works. BGP announces prefixes to neighboring networks. If we have a look at that world map, and again we have here my own network, and I'm announcing these 3 prefixes, and I announce it to my neighbor. And my neighbor receives the announcement and puts the information where he got it from into that announcement before re-announcing it to his neighbor. And again, the network who received that prefix puts the information where they got it from into the announcement when re-announcing it to their networks. So we have here a path of where that announcement came from. You see that with the colored dots in the announcement. So in detail, BGP announces prefixes to neighbors, and these neighbors don't find themselves, they have to be configured. And each BGP speaking device is part of a so-called autonomous system. You've seen that I'm saying I'm AS 196610. This is my autonomous system number. And the recording I showed in the past with the colored dots, that's called the autonomous system path. That's the path this announcement has traveled so far. So the blue one announced it first to the green one, who announced it to the orange one. This is the autonomous system path. And in reality, there are no colored dots. There are numbers in there showing who has forwarded that prefix announcement. And the rightmost autonomous system in the path is also called the originator. So that network which actually hosts that prefix. The others have just forwarded the announcement. The originator, this is the home of the prefix. So I mentioned a term here, autonomous system. What is an autonomous system? Also a very important term for understanding BGP, Border Gateway Protocol. So the simplest definition of an autonomous system is a group of IP prefixes who have something in common. The formal definition says an AS is a connected group of one or more IP prefixes run by one or more network operators which have a single and clearly defined routing policy. So a group of prefixes which have something in common, and that's a routing policy. We got into detail later what that means. At the moment we say to route or announce prefixes, you need some hardware, you need a router, and the router or multiple routers, they speak BGP, Border Gateway Protocol, to its neighbors and identifies themselves with an autonomous system number. So they are part of an autonomous system, and the autonomous system number identifies that autonomous system. And my AS number as the DE-CIX Academy is 196610. So we have another new term, and that's the autonomous system number. What is it, and how do we get one? An autonomous system number, well, you can read here the formal definition. It's a 32-bit number identifying an autonomous system. Originally, when BGP was invented, it was a 16-bit number, but it was noted around the year 2000 that we are running out of numbers, so the number space was extended to 32-bit. Autonomous system numbers are globally unique. So each autonomous system number exists only once and identifies exactly one autonomous system. And if a number is unique, you need to have somebody who administrates these numbers, who hands them out, and who keeps track which number has been assigned to whom. And that entity is the IANA, and that's the Internet Assigned Numbers Authority. But, well, the IANA, well, it's a small organization and there are a lot of ASs, so the IANA has delegated the task of administrating AS numbers to the 5 regional Internet registries, and in Europe the RIR or Regional Internet Registry responsible for administrating autonomous system numbers is the RIPE NCC, and with this small map, if you're not from Europe, you can see which RIR is responsible for your region. Okay, back to BGP and announcing prefixes. I spoke about neighbors. My router, my BGP speaking router, is connected to another autonomous system and their router, and I'm announcing prefixes. All these neighbors, they have to be configured. BGP routers do not find themselves. And BGP uses TCP, the Transmission Control Protocol, to connect to a neighbor. If you want to learn more about TCP, have a look at my video out of the Networking Basics series. TCP already brings reliable transport, so the sender of a message knows that the receiver got it. TCP also brings flow control, do not send faster than the receiver can receive, and framing. So put the messages into packets that they can safely travel from the sender to the receiver. That all brings TCP, so BGP doesn't have to reinvent the wheel to operate. BGP works incremental. When you configure a neighbor and a BGP session is initiated, at the beginning, the BGP speakers announce everything they know, all prefixes they know about to its neighbor. And once the session is up, all updates happen incrementally. So if there is a new prefix to be learned, the BGP sends an add message to the neighbor. And if a prefix goes away, the BGP sender sends a withdraw message to the neighbor. And as TCP is a connection-oriented protocol, so you set up a connection, you keep it alive, and you know that your neighbor is still there, the BGP routers assume that they are in sync. So I'm announcing prefixes to my neighbors, I'm withdrawing prefixes, and I always assume that the neighbor has kept that in sync, so the neighbor knows everything I ever told him or has forgotten everything I ever withdraw. That's how BGP works, incremental. And that keeps, of course, the traffic low because the initial setup has only to happen once when the session is established. Short example, again, with announcing a prefix, I'm adding my AS number, announcing the prefix to my neighboring AS. They add their AS number in front. They add their AS number in front when re-announcing. So we're building up an autonomous system part here, and we have the originator on the rightmost side. So characteristics of BGP we learned about today. We have prefixes. BGP works by announcing prefixes. We have autonomous system numbers, 32-bit in length, centrally administrated, and you can get one by talking to your regional internet registry. And we have an AS pass, and that notes all the ASs the announcement has been forwarded through. And on the right-hand side, we have the originator AS. That's where the prefix is homed, is hosted. And all the other ones are only the ones who forwarded that announcement. BGP announcements not only have the AS pass as an attribute, there are other attributes in the BGP announcement as well, and we will learn about them in the next videos. In general, there are two types of attributes. There are mandatory attributes, ones that have to be there. For example, the autonomous system pass, it has to be there. And there are optional attributes. They don't have to be there, they are optional. MED, we will learn about that next video, is such an optional attribute. You can also characteristic attributes in a different way. You have transitive attributes. Transitive attributes are kept on the prefix and forwarded via BGP from one autonomous system to the next. And we have non-transitive attributes. Non-transitive attributes are added to the prefix and removed either before forwarding or immediately after reception. Non-transitive attributes and transitive attributes. If a router receives a prefix, like I said, BGP neighbors announce prefixes not just to one neighbor but to all of their neighbors. So usually it happens that a BGP speaker, a router talking BGP, receives one and the same prefix from multiple neighbors, and they need to decide which of these prefixes is best, so to which of these multiple neighbors then to send traffic. Only one best route for each prefix goes from the BGP table, from the BGP part of the router, into the routing table. And this is done by an algorithm called BGP Best Path Selection, and I'm going to talk about that in the next video, how that actually works. For the moment, just remember, BGP announces prefixes to neighbors, BGP receives prefixes from neighbors, and you can receive information about one and the same prefix from multiple neighbors, and BGP needs to decide which of them is best. And that's it for today. Thanks for listening. I'm Wolfgang Tremmel from the DE-CIX Academy. Bye bye.